So last class we ended with the difference in a theory and a law. And what we said was that theories explain why nature behaves a certain way. We said they were well tested, but there's a chance that somewhere down the road with more knowledge, they could be tweaked or they could evolve as we learn more and understand better. And then we talked about a natural law or a scientific law. And we said the key thing to think about with a law is laws describe how nature behaves. They simply state a fact. They tell you what happens, but not why it happens. So I want to start off today's lesson with a question for you. I'm going to show you a statement, and I want to know if it's a theory or if you think it's a law based on the definitions that I gave you. So the statement says matter is neither created nor destroyed in a chemical change. Matter is neither created nor destroyed in a chemical change. What do you think, a theory or a law? Well, remember, theories are things that can evolve over time. They tell you why nature behaves a certain way. So is this telling us why matter can neither be created nor destroyed in a chemical change? No, it's not. It's just simply stating the fact that matter is neither created nor destroyed in a chemical change. So this is a law. It's one of our laws that we're going to learn about called the law of conservation of mass. And I typically abbreviate that LoCoM, LoCoM for short. But you cannot create nor destroy matter or mass in any chemical or physical change for that matter. So let's talk about what matter is, properties of matter. Roman numeral 3 is the properties of matter. Well, matter is what chemists study, and matter is anything that has mass and takes up space. Now, the amount of space you take up is called your volume. So matter is anything that has mass and has volume. It has to meet both criteria. Now in science, there are quite a few words or terms that in common vernacular people speak in, they use them interchangeably. And this next term is one that a lot of people say mass, or they say weight, as if they're interchangeable, but they're not. So let's look at the difference between mass and weight. Mass is the amount of matter an object has. So if you think about all the atoms that are in the object, is how many atoms are packed into the object. So the mass, when you measure the mass of something, it's the amount of matter that the object has. And mass remains constant with gravity. So like if you go to somewhere where the gravity is different, the mass is still going to be the same as it was initially. Mass does not change at a given point in time. If we were to all jump in a spaceship right now and we were to travel or teleport to the moon, our mass would be exactly the same on the moon as it is here on Earth, because we would not have lost any matter along the way. Mass is measuring how much matter an object possesses. Weight, on the other hand, is a measure of Earth's gravitational pull on matter. So on the Earth, you're going to weigh more than you're going to weigh on the moon, because the moon's gravity is 1/6 what it is here on Earth. So weight is the measure of Earth's gravitational pull on matter, and weight will change if your location changes. So let's think about this for a moment. Where would your mass be the greatest? We just talked about mass and weight. Where would your mass be greater, on the Earth or on the moon? Think about that for just a minute and try to answer it in your mind. Where would your mass be the greatest? Well, hopefully you said that it would be the same in both places, because we just said that mass is constant. Mass is not going to change because your location changes. Whether you're on Earth or whether you're on the moon, your mass will remain the same. It's your weight that would vary. Mass is constant and does not vary by location, or gravity is not affecting it. Weight varies with location, though. Weight depends on gravity. So on the question number 1, it will be the same in both places. Where would your weight be greater? Let's look at question 2. Where would your weight be the greatest? Well, your weight's going to be the greatest wherever the gravity is the greatest, because gravity will be pulling harder on an object. If it were on Earth, that means that the weight would be the greatest on the Earth. Okay? So hopefully you got both of those right. Now we come back to the law that I talked about, the law of conservation of mass, which is also sometimes referred to as the law of conservation of matter. LoCoM is a way you can abbreviate that if you'd like to shorten it. So this is one of our first scientific laws that we learn about. It says that mass cannot be created or destroyed in a normal chemical reaction. Mass can neither be created nor destroyed in a normal chemical reaction. You can't create mass that was not there. You can't destroy mass or matter, not in a chemical or a physical change. So let's think about how we would apply that to a chemical reaction. Now, in this example, I'm giving you just no chemical formulas that are specific, just letters representing atoms or molecules that are reacting. So hopefully you remember from previous sciences that in this case, A and B would be called our reactants. And so here we have A plus B yields, this is your yield sign, and then C plus D are produced, so we call the things that are produced the products. So remember, reactants yield your products. So in this case, A and B are reacting, and they undergo a chemical change, and they change to two new substances, C and D. So if we want to apply the law of conservation of mass to this concept, let's take a look at some numbers, some quantities. So here we have the reactants, 12 grams of A reacting with 8 grams of B. And it's going to yield some mass of C plus 5 grams of D. So if we apply this concept, mass is conserved, what does that mean? It means you can't create it or destroy it, so it means it has to be the same on both sides. So you treat your yield sign as an equal sign class. So let's look at the reactant side. 12 plus 8 gives you 20 total grams on the reactant side. That means when the reaction is all said and done, you have to also have a total of 20 grams, because you cannot create mass or matter that was not there in a chemical or a physical change. So let's do a little bit of algebra. What number plus 5 is 20? That's right. Hopefully you said 15 grams. So that's how you would approach a question when you apply the law of conservation of mass to a chemical reaction. Always find your yield sign, that is your equal sign, and then make sure both sides, mass, equal one another.